Hello everyone, in this video let's solve a question which is based on array and the problem name is find subarray with given sum. If you are new to the channel then don't forget to subscribe the channel, more videos about coding will come soon. Now let's understand the problem statement. So an array is given to you and a number which is say s is given to you. So in the problem says you have to find a subarray whose sum will be equal to the given sum. So if you see this subarray which is 2, 11, 6, this subarray, and if you add all the elements of this subarray, then you will find that it is equal to the given number which is 19. So 2 plus 11 plus 6 will be 19. So this is the problem statement. Now we'll see two solutions. The first one is the naive solution and then we'll see the efficient solution. So naive solution, so this is, let's say, naive solution. So the time complexity naive solution will take is order of n square. So the idea behind this solution is to find all the subarrays, and then after finding all the subarrays you have to check whether their sum is equal to the given sum or not. So you can use nesting of loop for that. So for nesting of loop, you can do the nesting of loop and then you can add them, add the value, and then you can check if the value is equal to the 19 or not. So obviously this is not code. Let's understand. So you for suppose I, this is our I. So what you can do, you can run j for this whole part. Okay, then you add whether it is equal to 19 or not. So if it is not equal to 19, then you move the I. Now I come to here. Then again you run the inside loop which is j for whole part. Then you see whether the sum is equal to the 19 or not. Okay, now you come to I here and then you run the j. So you will find for this I to j the sum will be equal to the 19. So this is nesting of loop. So for each I you are running in a loop j times. So it is nothing but I into j. So that is like for first time you are running n minus 1 times, then next time you are running n minus 2 times, then next time you are running n minus 3 times, and so on. So this is nothing but sum. If you sum this, so it will be n square. Okay, so it is of order of n square time complexity solution, which is a naive solution, nesting of loop. So we do not want to do that. So this is not a good way to do this question. Okay, so we are going to see the efficient solution. Now let's see the efficient solution, which will be done in order of n. So let me write here efficient solution, and this solution will take order of n time complexity. Now let me write the given array again. Okay, and these are the indices. This is the array A. Now for what we are going to do in the efficient solution, let's first see the logic. So what we are going to do, we say this is our I. Okay, and also we have j, which is also pointing to the same element. Now j will run. Okay, you will increment the j and then you add the values. So let's say in the total variable we are adding the values. So first total is 7. Fine, total is nothing but total plus 7, total plus a of j. Okay, and the thing is, first the total will be 0. Okay, now total will be 7. So you will compare, is it equal to the 19? So you say no, it's not. Then you will increment the j. Okay, you do not have to touch I until the sum become greater than s. Let's see, you'll get it. So you will first increment the j because sum is not equal to the 19. So you increment the j. Now you add the j. So now total was 7. Now you'll add 5 into it, then it will become 12. So it becomes 12, which is not equal to the 19. So you will again increment the j. Okay, now this time 12 plus 2 will be 14. Okay, now again you will increment the j because total was not equal to the 19. Now this time when you add the 14 plus 11, it will become 25. Now the problem here is 25 is greater than 19. So adding more numbers will be of no use because already you got 25. So if you add more numbers, it will become bigger number. There is no use of adding more numbers. So what you have to do now, you have to decrement the numbers. And how you are going to decrement that? You'll run I. So you'll run I, you will increment the I, and every time you will increment the I, you have to decrement the value from this. So you increment the I, so I will come here and it will decrement the 7 because I was 7, so it will decrement 7 from it. So 25 minus 7 will be, so it will be 18. Now 18 is smaller than 19, so you do not have to increment I again because now the 18 is, now the total value is smaller than the given value. So you now increment the number. So again you will start the increment the j. So you increment the j and you add it into the total. Again you add 18 in again you add 6 into the 18, then it will become 24. Now 24 again becomes bigger than 19. So what you have to do, because the given number is smaller than the total, there is no use of adding more values, so you have to decrement. So for decrement you again increment the I, so I will come here and you decrement it 25 from the 24. So 24 minus 5 will be 19. As soon as you decrement it, you will find that it equal to the given sum. So this is our I. Okay, so I is here and j is here, and now you can see you will stop the whole process because the total becomes equal to the sum. So now you can print I and j. So you can print I and j, which is I is at 2 and j is at 4. So this is the positions of this sub array which is equal to the given sum. Now let's see the quick code. So we are going to run the, so we'll take the total which is equal to 0. Now we are going to run for I is say for j is equal to 0 to j to n, and j will be increment. Now you add the total plus is equal to, which is total is equal to total plus a of j. Okay, now you have to say if not if, while given as is smaller than total, that means total is greater than s, and also I has to be smaller than j. Fine, because you do not want to increment the I value more than j. That is like whole process will be wrong, because you have to find the position, starting position and end position, and you do not want the start position to cross the end position. That's why you also check that I is smaller than j. So now what you are going to do, you have to decrement the total value a of I, and also have to increment the I. So until total remains bigger than s, you have to decrement the value, and I is the pointer which will increment and then decrement the values. So this is how it will done. So once again the value becomes smaller, again the total value becomes smaller than the given s, then what you have to do, you have to check if a of, so if total is equal to s, then you can see out the I value and j value, and then you can return, that is you can stop the whole process. So this was the whole problem. I hope you will get it, and the main aim was to get the logic. If you find any issue with this code, let me know in the comment, otherwise this code will work. It was an easy problem. So thanks for watching this video. Don't forget to subscribe the channel. More coding problem will come soon. Thank you.